all of your faces ready to learn today. Okay, so as usual, our topic, our unit that we are doing is number patterns in God's creation. My deep hope for this unit is that we may be creation enjoyers and God worshippers as we celebrate God's design through number patterns that we can find in creation. So, last week I had mentioned about creation and I had talked about creation and then we had talked about the fall. So creation was that God created all things, and because he created all things, numbers and patterns are things that God created. Now, because of the entry of sin into the world, patterns in creation were affected, but they are still beautiful. Last week I had given you guys and I had asked you guys a question about patterns and numbers. But if we have patterns in numbers, we also have patterns in creation. What are some examples that you can remember that you wrote in your homework last week that you have seen patterns in creation? Where have you seen patterns in creation? Anybody remembers?
Miss,
Yes?
if it is a rational, it cannot be an irrational, Miss.
Okay, those are patterns in numbers. Very good. That is one example of a pattern. If you have a number being a rational, automatically that means that it is irrational, and that is going to apply for all of the rational and irrational numbers. That is one example. Now, if we talk about nature, let's talk about things that are outdoors. Where have you seen patterns before?
In the leaves of the tree?
Very good, very good. If I go and I bring down a leaf from a mango tree, are all the leaves of the mango tree look similar? Or they look almost the same? And if I take and I bring down the leaf of an avocado tree and I compare those two, they're gonna be different, right? They're not gonna be the same. And those are what we call patterns in nature. So let's continue. Redemption. God has a plan to bring creation to its original design. Now, everything that we see, if it looks pretty, if it looks ugly, if it looks beautiful, whatever we look at has been affected by sin. So imagine in your head that you're walking in the jungle and then you reach a waterfall, and to you the waterfall looks amazing and it looks beautiful. But guess what? That waterfall has been affected by sin. And because of sin, it looks like that. So imagine how it would have looked like if sin had not affected it. It would have been even more beautiful. Alright? Next week we're going to talk about restoration. So now we're going to continue. Last week we had done classifying types of numbers, and we are no longer going to be talking about those types of numbers. So what we talked about, rational, irrational, and everything else, that was last week, and today we're moving on to something else. This week we are doing number 2 and we are doing number 3. State place values of a digit, and that's what we're doing today. And convert number bases, and that's what we will be doing for the rest of the week. Our essential questions: what story does a pattern tell? And why are there so many patterns? So today's lesson, we are going to be distinguishing between number systems. We're going to talk about different number systems, and then we're going to convert number systems. This is what we're doing this week, all right? So today we're talking about number bases. Today we're just doing the basics. We're going to talk about place values of the different types of number bases, and then we're going to talk about the number bases that we want to learn about this week, all right? So, determining the value of a digit. if I tell you, and if I give you a number and I tell you, okay, 127 has a 1, has a 2, and has a 7. And I tell you, give me the value of the 2. What are you going to tell me? What can you tell me if I tell you, give me the value of the 2? What are you going to tell me?
Unit.
Okay, you can tell me how many units. Very good. What else can you tell me? Nothing else? Nothing else, guys? You can't tell me anything else? Let's see. A value of each digit in a number can be determined using 3 things. You can tell me the digit. So you can tell me, okay, it's a 2. You can tell me that. Everybody can tell me that. You know how a 2 looks like, right? You can tell me the position of the digit in the number. So you can tell me, okay, the 2 is in the tens place value. You can tell me that. And you can tell me one more thing, and that's what we're going to be concentrating on this week. You can tell me the base of the number. And the base of the number, of any number that we talk about, is base 10. And we're going to talk about why. Alright? So, reviewing again, if I gave you a number, 1567, and I highlight the 5, you can tell me, okay, the value of that number is 5. I can see it's a 5. I can tell you it's a 5. I know it's a 5. You can tell me that, right? You can also tell me the position, the place value. Okay, ones, tens, hundreds. So the 5 is in the hundreds place. You can tell me it's a 5. You can tell me it's in the hundreds place. And you can also tell me the base. And in this case, the base is 10. Alright? So 3 things that you can tell me about a digit and its value. Let's move on. I want you guys to tell me the value of each of the highlighted numbers by telling me what the digit value is. So this is the first one. This is this one. I want you to tell me the digit value. Alright? So the first one, what is the digit value of this? The highlighted one.
6.
Very good. The second one.
1.
Very good. Next.
6.
Very good.
2.
2. Very good.
1.
Very good. And 1.
1.
Excellent work. Very good. Very good, everybody. Next. And we're going to use the same numbers. But now I want you to tell me the position. I want you to tell me the place value. Alright? So what is the place value of this highlighted one?
Ones.
Ones place. Very good. Next.
100.
100.
100.
Very good. This one.
100,000.
100,000. Excellent work. Next one.
10.
10.
Very good. This one.
Million.
Millions. Very good. And the last one.
Thousands.
Thousands. Very good. Very good, everybody. You were understanding. Very good. So, that is talking about place values, right? Now we want to go to the third way, and we're going to concentrate on the third way. What is a number base? What is the base of a number? A number base is the number of digits or combinations of digits that a system of counting uses to represent numbers. A base can be any whole number greater than 0. So what does that mean? I can have base 5, I can have base 8, I can have base 7, I can have base 2, I can have base 16. I can have a base that is greater than 0. Alright? And we're going to talk about different bases. So, the base of a number system determines how many symbols are used. So, for example, if I'm talking about base 2, I can only use 2 numbers. If I am talking about base 10, I can only use 10 numbers. If I am talking about base 16, I can only use 16 values. Alright? So, if I talk about base 5, how many numbers can I use in base 5?
5.
5 numbers.
5.
Very good. Very good. So now we are going to talk about 3 different types of number bases. We're going to talk about the decimal numbers, we're going to talk about binary numbers, and we're going to talk about hexadecimal numbers. So now decimal numbers are what we call base 10 numbers, and those are the numbers that we use. The regular numbers that we use are base 10. We're going to talk about binary numbers, and binary numbers are base 2 numbers. So we're only going to be using 2 numbers when we go to that one. And then we're going to talk about hexadecimal numbers, and that is base 16. And base 16 uses 16 different symbols. And I'm saying the word symbols because they use numbers and letters and they mix it together to make a number. Alright, and that one is the one that is going to take us a little bit more time to learn how to do. Alright? So we're going to start off with the decimal system. And I'm not going to take too long on this because you guys already use the decimal system. Alright, like I said, the decimal system is the one that we use. Regular numbers. So I can talk about 0, 1, 2, 3, all the way to 100 to 150 to 200 to 375, all the way to infinity. All of that is the base 10. Now, why do we call it base 10? Because we use 10 different numbers. And there are 10 numbers that we use that make up all the other numbers. Who can tell me what those 10 numbers are? Anybody know? What are the numbers that we use that make up all the other numbers?
1 to 10 is?
Not really 1 to 10.
1 to 9.
0 to 9.
0.
0 to 9. Who said 0 to 9? That is
Me.
correct. 0 to 9. Why? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are those? 10 numbers. Now, why do we not include 10? Because 10 is made of a 1 and a 0. Right? If I talk about 27, what numbers make 27? A 2 and a 7. Alright? So the numbers 0 to 9 are the numbers that I use that make up all the other numbers. Right? So that's why we call it base 10, because we use 10 numbers. And they are right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we call it the decimal system. Another word for the decimal system is denary system. So if you hear me say decimal or you hear me say denary, I'm talking about the same thing. Two different names to talk about the same thing, right? Now, the decimal system has a place value chart, and you guys already know this place value chart. You have the ones, the tens, the hundreds, thousands, 10,000s, 100,000s, millions, and I could go on and on and on and on, and you know this. But when we talk about bases, we talk about powers. So I want to know, what is the ones place as a power? What is the tens place as a power? What is the 10,000s place as a power? How do I write it as a power? And it is important for us to understand this, because when we go to base 2 and when we go to base 16, we have to use powers to be able to solve these questions. So if I give you a number, who can read this number to me? Who's going to be the brave little one to read this number for me?
Yes,
Okay, let's go, Gerald. Read it for me.
983,275.
Very good. 900. 900 what? Did you guys listen?
83,000.
Did you guys listen?
Yes, miss. 83,275.
83,000.
275. Very good. Now I'm gonna put this number into that place value chart. And I have it there in the last row. Now, you guys already should know how to write an expanded form. So what I have at the bottom in pink, all of you should know how to do that, right? Okay, very good. I'm not gonna go over that. So, what are the numbers used for? If I talk about the decimal system, it's the numbers that I am using right now. So, our decimal system is the basis. All the other bases are made from our base, from base 10. So, all the other bases use the numbers that base 10 has, but they don't use all of them. It depends on which base I am talking about. Alright? Now we're going to talk about the binary ones. And you guys pay attention because I have a little quiz at the end of today's class. Alright? So you have to be paying attention so that you guys can do the little game at the end of the class. The binary system is base 2. So if it is base 2, how many numbers that I'm going to use?
2.
2 numbers, very good. And the first 2 numbers is 0 and 1. So binary only uses zeros and ones. So if you see a binary number, it's going to be 11100101001. That's how a binary number looks like. Only ones and zeros. Alright? So binary uses 0 and 1 only, and you have a place value chart for binary numbers. And it's important. Take a look at this place value chart. It has powers of 2. Why does it have powers of 2? Why doesn't it have powers of 10? Remember when we talked about the decimal and we looked at the first place value chart? It had powers of 10. This one has powers of 2. Why does it have powers of 2?
Because it's the binary system.
Because it is the binary system, because it is base 2. It's right there. Since the number base is 2, the powers have to be 2. So if I am talking about base 5, what will my powers be?
5.
Very good. If I am talking about base 8, what will my powers be?
8.
8.
Very good. And as we move along, the place value charts change because we're talking, it has to change according to each base that you are doing. So, I'm not going to talk about the hexadecimal today because that is whoosh, big, and it's going to be a little bit more difficult to understand. But hexadecimal, how many numbers and letters does hexadecimal use? Who remembers? I said it at the beginning.
16.
16. So you have all of those numbers and all of those letters. And how will my number look like? My number is going to look like 1A3C. That is going to be my number. And I have to know what that number means. So when I say, okay, I'm going to call on somebody and I say Mayeli, what is 2A3B? Tell me what is the value of that number. You have to be able to tell me what that number in base 16 means. Alright? So if I ask you guys a question, and this is what we're going to be doing, write the number 36 base 10, and I want you to change it to base 16. And you have to get an answer like 6E. That is going to be my answer. And 6E means 36. Right? So that is going to be a little bit more difficult for us to do. But we are going to be doing that not today and not tomorrow until the following class. Anybody has any questions?
No, miss.
No questions? Okay. So I have a little quiz. And then we're going to be talking about something else after the little quiz. Alright? Is everybody ready? I am going to put the link in the right now. I am going to put the link in the chat, and I want you guys to click on the link.